tech session, which is a joint effort between Splunk and PolyLogyx. And today we're going to be looking at a revolutionary new endpoint security product called PolyLogyx. And we have Atul Kabra from PolyLogyx, one of the co-founders, here with us today. So for those of you that haven't been on a tech session before, we always like to encourage you to download the Phantom Community Edition and poke around at the apps and playbooks that we're discussing here. We have a pretty active Slack channel, which is Phantom-Community on Slack. And then we have blog posts about tech sessions like these. And Slack is a great place if you have a question about something you're doing with Phantom. If you're developing a new use case, you can go on there and discuss it with some other like-minded members. But today, we're going to go into this new integration with PolyLogyx, and we're going to show a live demo of an infected Windows machine and how Phantom and PolyLogyx can be used to, first of all, do some investigation, and then actually mitigate the threat using the OpenC2 standardized protocol for communicating with mitigation devices. So that's all I have on the Phantom side for now. So I'm going to let Atul take over the screen and drive from his screen. Atul, do you have a button to share screen?
I do.
Great.
It's grayed out at this point.
Yeah, Alexis might need to give you some kind of permissions to let that happen. Is it still grayed out?
It is.
I'll try to. Another option might be for you to email me the slides real quick. Oh, there we go. Okay.
So, morning everybody. I hope you can see the slides here. Is that visible, Phil, at your end?
Yeah, it looks good.
Okay. Yeah, good morning everybody. My name is Atul Kabra, and I'm the co-founder and CTO at PolyLogyx. Myself and the CEO, Mr. Sridhar Jayanti, who is also on the call. We started PolyLogyx based on our years of experience in the endpoint industry, things that we had seen working or things that we had seen people constantly complaining about. Together, between Sridhar and myself, I think we have a few decades of engineering experience in endpoint industry across McAfee and FireEye, and we built a variety of products for these organizations. And no matter what, we always felt that there was room for improvement. I mean, endpoints is the most sensitive component in the security fabric. It's directly on the device that the user is interacting with, and users tend to be vulnerable. So it's obviously the most sensitive device. They often claim that the truth lies on endpoint. Network security is pretty good to detect and respond, but you never really know the extent of infection unless you know what's happening on the endpoint. Hold on, let me just see full screen. Okay. Geez. Sorry about that. Just let me figure it out. How this? Yeah, I'm sharing my full screen. Is it better now?
Yeah, that's about as big as it's going to get. That looks good.
Yeah, it's fine.
Yep.
Okay. Yeah. So yeah, the whole idea behind PolyLogyx was how can we make endpoint more easy to integrate with? Like how can we improve endpoints visibility and control in a way that it's not in a very proprietary API driven. It's very easy standardized language that you use to interrogate the endpoint and take action. So the ground up focus was on making it easy and standardized as far as possible and integrable. If there are other applications that need to talk to endpoint, they should be an easy way to integrate. Unlike typical integration that happened at the end of the fabric, which is on a SIM or somewhere even beyond that, our focus was on integration all along the path. So at the endpoint level, at the management server layer level, at the orchestration layer level, or even at the console levels for a SOC analyst. So with these basic principles, we wanted to bring it. So our idea was security problems can only be solved when there is a collective ecosystem of various technologies and products that can come together. And that can only come together when there are APIs which are sort of standard driven. If everybody has their own proprietary API that people have to code up to, then it's really not scalable. And maybe that's the mess we are in. With these simple beliefs, we started PolyLogyx, and naturally our expertise area was endpoint. That's where we started with, starting with our agent on that. All the way starting to create APIs that can be integrated for a SOC analyst and MSSPs. We took OS query as a choice because the form factor for OS query was indeed pretty flexible. I mean, almost everybody in the programming world has heard of or knows SQL to quite a great extent. And in the exploration to OS query, we figured out that it had some deficiencies on the Windows operating system, although it worked fairly well to some extent on every operating system. But for Windows, it was still sort of an incident monitoring or a resource monitoring tool more than a real capability tool for security. We took the endpoint platform that we had started and we created or extended OS query with a lot of real-time tables, so it can come at par with any other EDR agent. It starts recording all the information as they are happening, and that those information is easy to query because the top-level form factor for OS query is a very SQL-driven. So a lot of correlation can happen right on the endpoint just because of the query syntax, because you can do cross-table which process created which files during which time window, and a lot of when a user ID. Because everything, the SQL syntax allows you a great deal of correlation right at the endpoint level. We also extended it to build in some extensible extended features for memory forensics and static detection engine for ARA, and all these get collected as the events happen, and then they can be taken out of the endpoint. As the original use case for OS query, I believe, is more around resource monitoring with these new additional tables and the information that's been that it can provide. It is easily now an extensible tool for incident response or even forensics, threat hunting, the compliance use cases for things like file integrity monitoring and process audits with these features. OS query was a pretty good interface, or the SQL interface, to get the data out of endpoint, but you also need a bidirectional interface that can allow actions to be taken. So you get the data, you figure out something bad has happened, and now you want to remove the artifacts that look malicious. And at that point, we looked at the OpenC2 controls. OpenC2 stands for Open Command and Control. That's a new standard that's driven by the OSS group, which has in the past driven for Stix and Taxi. And I think there's a very big group, all the way including federal government and some of the biggest industry names. Phil probably knows more about it than I do. But the endpoint standard for the OpenC2 is still evolving. And that was the choice we took because that allows us an integration with a wide variety of devices. So a network device wants to apply its intelligence by taking an action on endpoint. OpenC2 gives that level of flexibility. As of now, or in the first version, we have implemented the file delete and process terminate commands. These are the first, probably the most important ones the moment an infection is detected. And the next one we're in the process of defining is how we can contain the infected endpoint. These commands are built on some sort of deep APIs in our platform. So even if the system is infected or if it is a hostile environment, cases at the back end.
Atul, I think we had a bit of an audio hiccup there. I just lost the last 10 seconds or so of audio. If you want to
Okay.
back to
Did you want me to start from OpenC2? Can you hear me all right now?
now it sounds great.
Okay. All right. As I was saying, that OS query was the form factor and the interface that allows us to get a lot of data out of endpoint, and we can do a lot of correlation across tables and a lot of simplification just because the SQL language allows for all of that. The other side of the equation is how do we take action once we know something unwanted has happened on the endpoint. We needed a mechanism to take action or contain it. And that's the place where we started looking at the OpenC2 syntax. OpenC2 is an industry, it's driven by OSS, that's the industry consortium of a large number of vendors and government and some other stakeholders. And the endpoint part of OpenC2. So basically OpenC2 is allowing cross-product, cross-device communication by creating an open command and control interface. And the endpoint side is still quite evolving. I think some other interfaces are probably more mature. And we started taking lead in defining the syntax for endpoint on what OpenC2 actions can be implemented and how we can integrate with products like Phantom and Splunk. As of today, we have implemented file delete and process terminate because these seem the most obvious ones on an infected system. If you see a malware activity, the first thing you want to do is delete the source of malware and the process that it has launched. The next one we are in the stage of formulating is the network isolation. So an analyst or a security analyst or for deep forensics can take the endpoint of the grid but still have connection to the endpoint and be able to do a deep forensics. All these APIs are built underlying some deep framework that we have created, and by deep I mean it allows all these APIs to work even if the system is infected. So now at the end of the whole machinery can work by configuring some real-time alerts and taking the action, and this is how the whole platform comes out together. These APIs are available, this whole OpenC2 action as well as the query actions are available as APIs for integration beyond the platform. So orchestration or an analyst console, any network product, or even some cloud aggregator solutions or cloud monitoring solutions, they can all make use of them. And these all are driven on a very, very standard interface, so it's not like very complicated vendor-specific APIs that one has to go through. This is, yeah.
Do you have more than one slide, or because I haven't been seeing the slides change. I'm not sure if it's.
Which one are you seeing?
I'm still seeing slide number 1.
Really? Oh, okay.
Sorry, I should have spoken up earlier.
I'm sorry about that. I'm changing the slides here. Okay. Let me see. Maybe I just reshare the desktop again.
Okay. Yeah, maybe.
Do you see it now?
Now, yeah, now we're seeing these.
And do you see them now?
But yeah, now we can see them. Yes.
Okay. Yeah. So this was the OS query and OpenC2 slide that I was talking about. I mean, most of the content I've already spoken to. So this is sort of the pictorial representation on how the whole thing fits together. And this is the schema of things when we move to the demo shape. On one end, we have the cross-platform OS query agent. And on Windows system, as I mentioned, we have created our extension that leverages the OS query form factor, but gives it the muscle of all the real-time event and the OpenC2 implementation. All this data from endpoint and communication happens through our routing system, our platform, on which you can configure alerts for special conditions. And the whole platform communication can happen using the REST interfaces. And there's a minimal web interface, but our main focus about integration is on APIs. So whether it's a analyst console, whether it is an orchestration product, it's a log aggregator like Splunk, all of them can suck data out of it and take action on this piece. As I mentioned, our focus is not as much as to create a complete product by ourselves, but our focus is to be able to create a community and ecosystem so that the collective knowledge and technologies can come together. That's the only way to solve the security problem. And hence the platform is being built up with that vision, that whether it's MDRs, MSSPs, and technology partners, they can all come together to create a superior offering in the end deployment. One of the other things that we looked at very upfront is to figure out how we can create some infrastructural knobs so it really doesn't become very expensive just to deploy an endpoint visibility platform. Bulk of the cost that's in data aggregation, data collection, data processing, we've tried to really optimize it, try to ensure that the duplication of cost can be avoided, and the bootstrapping cost of this can be as low as possible. In future, of course, the vision is to move to any endpoint anywhere. Today we are offering only on the corporate endpoints on Windows, Linux, and Mac. The next one obviously would be cloud endpoints, including the containers, and then some point move into the IoT space. So now it's a show time. I mean, this just to show how various technologies come together, with PolyLogyx sort of acting as a glue between them and get the whole thing going. Phil, do we do Q&A now or do we do it at the end?
Yeah, I would certainly like to hear questions now while we're focused, purely on PolyLogyx, because we're about to throw a few more, Phantom-specific items and a demo into the equation. So if anyone has questions now on PolyLogyx, let's just wait for just a moment to use the Q&A field to put those in.
No, not as of today. The extension for response is only for Windows, but that's the next thing. Like we want to carry on the same capability across all the operating systems. The first operating system was Windows, but the idea is we cover all this gamut of all the desktop, laptop endpoints, and then move to cloud. So yeah, the similar feature will be available on Linux and Mac very soon.
So Atul, we can't all see the questions. Just the way WebEx works. Which question were you addressing?
So the question was, can the extension delete process/files on Linux and OS X?
I see. Okay.
Yeah. I thought the chat went to all participants.
And that's certainly the hope with OpenC2 is that
yes.
that it grows to be able to support all sorts of different commands. Just to kind of level set here, OpenC2 is in a pretty early stages. We have not hit 1.0 yet, so we're still iterating on these commands. And this is, I would call this a reference implementation rather than kind of a 1.0 or even a beta release of OpenC2. So there's another question here for Atul. What about support for mobile, iOS, and Android?
Yes, so that would be the next thing that's following. I mean, we are exploring how we can port OS Cori on Android as the first thing, and the natural extension would be iOS and other devices. At this point, it's a little far. The first thing is to, already have the Mac and Linux to cover in the desktop territory, and then other cloud systems.
Okay, and as long as there are no other questions.
So there's one question, is the data encrypted when sending through OpenC2? The OpenC2, as far as, and then Phil can correct me, I don't think the standard specifically asks for encryption. I mean, it's just a sort of a schema. The transport will take care of the encryption, whether you're doing on SSL or which other means. But Phil, maybe you want to chime more on that.
That's exactly right. So there will be what we call transport profiles for the OpenC2 standard, and I'm pretty sure that HTTPS will be one of the first ones out the door, which is of course encrypted. And as far as the integration we're showing here, it uses HTTPS as well. So was that the question? Can you repeat the question one more time? Let's say?
Yeah, that's fine. I got the response and affirmation.
Do you see any more on your side?
No.
Okay. So we can I can share screen again, and we can start.
So I need to give stop share. Okay.
And since I think you have the ball now, Atul, so can you right-click on my name and
make
pass
it
it over to me? Yes. There we go. Okay, can you all see the Windows endpoint here? Atul? Yeah.
Yes, I can. Well, by any chance, do you have that slide that describes the use case? Or are you just going to talk through it?
Yeah, I can just describe it here. I don't have that readily available.
No problem.
So we can here I can show this. So what's happening here is for this demo, we're using a use case where there's a code signing certificate that's out in the wild. So if an enterprise that releases software had that stolen from them, and that's known to us, then we're going to be keeping an eye out for executables that are signed by that, which could be a way for an attacker to kind of circumvent some application whitelisting if we're checking digital signatures. So we have this test executable here, signed by PolyLogyx.com test, and that's going to be our detection mechanism, is a periodic search every 15 seconds using PolyLogyx that looks for portable executables on Windows that are loaded into memory that are signed by that certificate. So it's I think it would be a pretty reliable detection if we had this deployed, because false positives for that should be pretty low if it's a known stolen certificate.
And just to add to that, the event in the agent gets collected right at the moment the executable is loaded in the memory, and the query intervals decide when the event is pulled out. So it's not like that query time we detected.
Yeah, forgive me for that. Yeah, so the query is kind of as on the inside, but the PolyLogyx is done in real time. Is that correct? So here I am on PowerShell, and I just want to first show so the default downloads directory. Just show that there's nothing there currently. I'm running this from trial 11 is the directory I'm in here. Just to give you a little more context as we show what Phantom is doing. So I always forget that piece. Okay, there we go. So so this malware, it does a little bit of logging here, so it tells you it just turned off Windows Defender. It disabled the host-based firewall in Windows. It downloaded a secondary executable called listen, which it executed. And you can see that PID 19704 is the one that was just started. It also downloaded this file into the user's default downloads. And so you can see some level of visibility with Windows Firewall. And so we'll show a little bit of the investigation that's done on the Phantom side. So first I'll go to email just to be, so this is the initial ingestion. It looks like we already got the Gmail alert from PolyLogyx. So this is just one mechanism of getting the data across, is sending an email alert. And I'll jump into Phantom here, and it says 0 minutes over here, so this is the right one that just kicked off from the demo. And a playbook is already executing pretty quickly through here. So let me jump over to the playbook. So this playbook is set to active, saying that it's going to launch as soon as the email is pulled into Phantom. And in this case, the first thing you're going to see it do is check to see if the artifact name is PolyLogyx alert. And that's not an artifact that's going to be in the initial email, because the way email works, we're actually going to get email artifacts and hash artifacts. So this is just a mechanism we use in Phantom to kind of pre-process the alert. So you'll see here we're pulling out the important data by looping through the body of that email and just writing the correct fields here so that we can automate on it appropriately. So that could have been, this block here down at the bottom, this could have been done in a separate playbook, but since it was just one simple block, I figured I might as well encompass it all in one playbook. But what happens is that block writes the initial, that's the first run through, which you see has no actions. It just creates the artifact. And then the new artifact triggers the second run through that actually goes and does the main automation. So now we're into the main part of the playbook. We're going to get system info on the device, which is just basic information about the operating system and the hardware. We're going to list all the processes that are running currently using the IP and host name that we got from get system info. And then the query is just select all for processes. We're going to do a similar thing with the users table. So for those who are unfamiliar with OS queries, this is treating operating system level objects as if they were a SQL table. So select star from users gives us all the user accounts that exist on that particular system. Next, we're going to find the child processes. So here we dipped into a little bit of custom code, which basically says select from all the win process events where the parent path matches that executable that was loaded with the stolen certificate. And of course, we're not hard coding that, we're loading that in from the event itself. So in this case, image path is text session, trial 11, vast test malware signed.
So just to add, this is the advantage of the whole exporting the endpoint data as SQL table. You can refer to inputs into the next query as some previous ones out instead of having to hard code or do things manually.
That's right. Yeah, it's a very flexible, powerful interface. Just to give you an idea of the app that we have here, there's only 5 actions. So terminate process and delete file are the response actions. Run query is the action that we use for almost all of these blocks in the playbook that are doing investigation. And then get system info you can think of as kind of a convenience function that's just a special case of run query. So for instance, 1, 2, 3, 4, 5, sorry, 4 are all run query using that OS query interface. And that just gives you a huge amount of flexibility about what exactly you can detect on the endpoint. So let's see, we also want to define dropped files. So this is actually, I actually built this query in a little formatter because I wanted to drop something in. So select from all the Windows file events where time is greater than the current time that this was loaded from PolyLogyx. So that time window lets you look at very specific windows on the machine so you're not overloaded with all the file events that are happening on Windows. As we all know, it's a very busy environment. There's a lot of things going on, so we don't want to be looking at all that.
Yeah, so that's you just get the targeted data instead of bringing all that bazillion records onto the console and then sift through it, causing network choking.
That's right. Yeah. So that's the before I get into the response part, I'm going to go ahead and do what an analyst might do and look at some of the results of this investigation. So we got the system information, and we have the CPU type, we have the host name, how much memory, how many cores. You know, it's the fact that it's Microsoft. Just happens to be a VM, of course, because it's a test environment. And then we went ahead and we listed all the processes. So that's a large file. So you could download that and look at all the metadata for all the processes. You know, for the users, we have, of course, the default account on the system. We have guest. We have a username called test. We have a tool has his username here. So you can see that we're listing out, you know, all the different built-in and custom users on this system. Here I'm doing a more targeted query using the actual path that was pulled out of the alert. So I'm digging in and saying, okay, what processes were spawned off by this? And here we start to get into some of the threat behavior on this particular endpoint. Just glancing at this, you know, I can see PowerShell being used to turn off real-time monitoring, which I believe is connected to the Windows Defender piece that we saw got turned off. Another similar one, so we're getting, you know, the process create events as well as the process terminate events, so we can get the exact timing of some of these things if we want to do follow-on queries about, you know, what else was done with PowerShell, for instance. In this case, he's, you know, turning off the host-based firewall. So this is all pretty suspicious stuff. Invoking a web request, so basically pulling down files onto the operating system. So we saw that directory was empty before. Now it's pulled down malware.txt. And then we saw it start off that child process, listen.exe, which is opening up a TCP port to listen for command and control. And then we're seeing some other of the process terminate events that were tied to some of the ones we started earlier. So a pretty quick view already of what's been done by this process.
The malware used a code sign certificate to get the first pass evasion, and then it turned off the existing antivirus and then pulled the next stage malware and then looking for commands on the socket.
Right, and so yeah, it's a pretty good piece of test malware. I'm kind of scared if a tool was an adversary I had to deal with. So let's go back to the playbook. So that was the investigation piece. So let's go into some of the remediation. So we had child processes here. Let's go ahead and kill those processes. So let's pull out the exact paths that came back. Sorry, not the paths, the process IDs that came back from that child process query. And now we're going to switch over from using OS query to do investigation. So now this is an OpenC2 command that actually gets sent. Which I believe is one of the first times that OpenC2 is being used between two commercial products, since it's early days for the standard. So we actually are sending that payload across the wire, so we don't have to build anything specific to PolyLogyx to actually write that command. So let's see what happened with the command. It looks like some of the other ones failed, probably because those other processes were already killed. But the one that did succeed has a message that says process stopped. So let's go back onto the Windows machine and be sure that yes, in fact, there's no more listen.exe running. So that child process did get killed on the Windows machine. So this is kind of the kind of remediation where, you know, we didn't check in with an analyst. We just did this automatically in about 30 seconds to a minute or so. So, you know, that could really disrupt a malware operator who expected to just quickly drop a couple files and continue on with their detonation workflow. So we then went in back to the playbook. We went in and we looked at any files that were dropped again, so that file events table, and then we ran those against VirusTotal to see if they were known suspicious, and if they were, we went ahead and delete those as well. So let's see how that played out. We ran, you know, one file against VirusTotal, and it hit 53 of the edges out of 59. So that's about as bad as it's going to get. So we passed that on. I think our threshold in this case was 10 positives. Obviously, it's configurable, but it definitely matched in this case. So we went in and we deleted that file. So users default downloads malware.txt. So let's jump in there and see. And yeah, we deleted malware.txt. And then the final piece of the playbook was deleting the actual malware itself. So the piece that kicked it all off, of course, you don't want to leave that sitting on disk. So it went after that vast test malware sign file, which was the one I initially executed. And as you can see, it's no longer in this directory. It's only the listen when it's dropped. And of course, in a production environment, as you take this playbook in, you'd probably want to create tickets, notify other users. But a lot of that stuff is custom to your environment. So in this case, with this playbook, we're only addressing the mitigation and the investigation parts in the playbook. So I think that was all I had for the actual live demo portion. I know for our audience, there's probably various levels of familiarity with PolyLogyx and Phantom. So we'd really love to hear some questions. It's only 38 minutes past the hour, so we have time for a Q&A. First, I'll give it to Atul if you have any more pieces that I missed that you want to add to what we did in the demo.
No, that was pretty good. I just wanted to highlight that these are not the only tables. There is a much wider variety of data capturing that happens on endpoint. You could actually look at the URL that has been triggered, the DNS queries that have happened, but this whole playbook is just sort of a sampler as to how end-to-end workflow would happen. But there are other kind of analytics on the same system that could be built.
Right. And
yeah, somebody mentioned that the questions are private. I just want to know that I received one question on chat, which is about how is the data being collected through a PubSub framework or through an internal SQL mechanism. Internally, we collect the data through our own PubSub framework. The interface to get that data out of the collection system is the SQL interface. So it's kind of that. Any other questions, suggestions? Good, bad?
I'm not seeing any more on my side. Oh, here's a question. Okay. Okay. So the virus total lookup is only when you initiate it. So I think the question is, I guess I'll go back to the playbook. I believe the question is asking here in the playbook when we do virus total, is it asking a human analyst before doing that? And the answer in this case is actually no. This is a fully automated workflow. So we took in an event. We did a lot of other things, but in this case, we built a query against OS query looking at new file events in the last however many seconds. In this case, it came across in about 30 seconds, so it's only going to pick up about 30 seconds of operating system activity. But there could be false positives in there. So we did a file reputation automatically on, and sorry, I have to be in mission control to show that we ran one query on virus total. It could have easily been 10 queries or 50 queries. Just depends on how busy Windows was at that particular moment. So if you wanted to not run this until someone in your organization had approved the usage of virus total, you could actually go into the action settings, and you could set a reviewer. These are all the users. So you could say, well, one of my security engineers needs to review that before it's done. So just like that, I've actually added the approver so that it won't be done. Of course, aside from your usage of your VirusTotal license, another reason you might do that is if it's a very sensitive file that you don't want to be uploaded to VirusTotal. Because I know executables on VirusTotal can be searched. So if you have a paid account, so you might have a sensitive executable that your company has developed that you don't want to get there. So it's definitely a good question to ask, something I'm a little bit concerned about with these playbooks. So if you feel like you want to put approvers on these sort of things, I think it absolutely makes sense to do that. See, I have to get out of sharing screen to get back to the list of questions, I think. But whoever asked that question, if you want to just let me know if I answered the question appropriately, if that was what you were asking. Atul, do you have any more questions on your side?
No, none on my side.
Oh, here's one. Okay, it says, where are the run query options documented? So as I pointed out, there's an advantage to having an option like run query, which is a very flexible action. But the downfall there is, well, in this particular case, we could have done a much better job. This is the documentation for run query, and it needs to add a lot more before we fully release it. But the real answer to the question is what can you query with OS query? And some of that information is in the PolyLogyx documentation, and then there's other information on osquery.io if you want to get full walkthroughs of what's possible. I'm not sharing my screen anymore, am I?
No, you're not.
Okay, so I'll just jump in really briefly. There's a lot of good documentation here on osquery.io. PolyLogyx exposes all the tables that they're exposing, which, as Atul mentioned, is significant. It goes above and beyond what is available in the free version of OS Query, in the open source version of OS Query. So there's a huge amount of possibilities with these different things that you could access through that one run query action. And then literally, if you're just asking the parameter that goes into the object, there's only two. There's the query itself, which is a SQL string that ends with a semicolon, and then there's the IP host name, which is the endpoint that you actually want to query. So basically, there's three main sources of truth there. There's the literal parameters, there's the PolyLogyx tables, and then there's the OS query itself, which uses SQL.
There's one more question. How do you collect the logs from the endpoints? This is the endpoint. On the agent, we are collecting the data in real time. We have our kernel extensions involved that take the action, that store the action in our database as the action happens. And at the top level, there is the SQL interface. The data that is captured is exported as SQL tables, and using those interfaces, the data can be taken out of endpoint. Does that answer the question? Or was it more something else?
Yes, but so I think on the Phantom side, in this case, we're only accessing it, per query. So we're not currently streaming all of that data into Phantom. We're only getting that which is actionable for this particular use case.
And I believe there's one more question is, can you, instead of deleting the malware, can you quarantine? So that's in the works. That's what I showed in my slides earlier. But the next thing that we want to do is, we implemented 2 actions on the endpoint right now, which is deleting a file and terminating a process. And the next one we're going to do is the quarantine. That's in the works. Certainly possible.
Right. So there's actually 2 possibilities there. We can quarantine the Windows endpoint itself at the network level, and then there's also, I know some products quarantine specific files. You can put that file, you can encrypt it and put it into a different directory so that the user's not going to see it anymore, but that we still have access to it. Atul, do you have a preference among those 2? They're obviously very different, and there's different use cases for both.
Yes, I think the easiest one is the quarantining the endpoint. For process one, you have to have like really high fidelity intel or real high fidelity output of your analysis, because it may give you a false sense of comfort that I've terminated or I've contained my process when the infection may have actually spread. So the best, I mean, in my experience and in my understanding, it's best to just contain the endpoint, do deeper forensics, and re-image it.
Right. And hopefully one day we can do an end-to-end workflow that actually shows all of that being done, because I think that's also something that people would like to automate, since it can be a timely process, a time-consuming process.
Correct.
I'm going through the questions here, seeing another one about instead of deleting the malware. Oh, I'm sorry, that's the one we just covered. The question was, I'm not sure that the first thing to do is delete or eliminate the malware or malicious processes. It's true it's not always the best immediate action, so it really depends on the use case. And another comment was, simply deleting a piece of malware on the endpoint might have some highly undesirable side effects. That could definitely be true, particularly if it's not actually malware, if it's a legitimate executable. So I think that some of that can be done with VirusTotal and other reputation engines, and then some of it could probably be improved with smarter queries for looking exactly what a given process is doing, as opposed to just deleting the malware or deleting the file right away. So I definitely agree that there's room for improvement here with taking automated action. And another option is to bring a human into the loop and simply enrich a decision, which a lot of our customers get a lot of value from, not going all the way to full automation, but basically building a case against why Phantom would act a certain way, and then getting right up to the point of sending the command, but allowing an analyst to actually review before doing it.
Yeah, I think the whole automation piece can definitely speed up the process of investigation for an analyst, because a lot of it could just be noise and easily, or some of them could be very high fidelity indicators that could easily be taken care through automation, and can minimize the human involvement. Another question says, use workflow to disable networking on a compromised endpoint. Is that a question or is that a statement? I'm not sure.
Yeah, as we mentioned, I think it would be a good thing to come back to this at some point in the future when we have more quarantine options with PolyLogyx and Phantom, and show a playbook that actually uses those, which I think we mentioned earlier. But I think it's a great ask as far as something we should be able to do in an automated fashion. So it's our job to get that out to folks.
Yes.
And then a final question here is PolyLogyx a free tool, or does it have a paid version?
The agent version, just the bare agent binary, is freely downloadable from our website. But the whole solution is a commercial in nature. If you just want to play around with the agents, each capability, wire it up to one of your solutions, please, you're welcome. Download it from our website. If there is a more deep ask or a more complex ask, we're happy to help in other manners.
Okay, I think we've covered all the questions I saw. Oh, actually, there's a new one there. As soon as I spoke. Yeah, so people have some concerns about loading multiple endpoint agents on endpoints.
Yes. So being in the endpoint industry for the largest part of my career, I completely agree. And this is one of the things we wanted to solve with PolyLogyx, that instead of creating a whole blown agent, why not let's take an existing agent that has a very nice form factor, add more technology into it, so everything is a single agent, and we can combine and we can evolve it as more and more needs come. The PolyLogyx, so the question is, how does the PolyLogyx agent play with OSSec or Splunk Universal Forwarder? PolyLogyx agent can spew the logs out in multiple places. Currently, we bring the logs onto our server, and from there it will be forwarded to the Splunk. If somebody wants to people have done creative configuration with OS query, the basic OS query, have OS query dump the data into system log and have the forwarder read from there. Our preference is we bring the data to our central routing server. That gives us the opportunity to apply alerts and some kind of analytics and pop out something which is not looking normal, and then have the forwarder read it from there and push it to Splunk. You're welcome.
And I think that was all I saw on my side at the moment. We can give just another minute or so in case people have more questions. And again, I'd like to echo, the fact that both Phantom and PolyLogyx have free downloadable software that we would encourage you to take into your environment, try out for, start with one simple use case and just try to prove it out, and I think you'll be happy with the results.
Yep. I and feel free to reach out to me or anyone at PolyLogyx on email or through our website. If there are any questions, we can answer at the right point in time.
And I think I think that was all I had. So thank you very much, Atul and Sridhar.
Thank you very much, Phil and Phantom, and giving us this opportunity. Really, really honored and happy to be here.
Okay. Have a great day, everybody.
Hold on, I might just have one more. Okay, sure. Yeah. Okay, thanks. Yeah. Everybody have a good day.
Okay. Goodbye.
Bye.